Hello all. In this video, we'll be discussing about LeetCode problem number 14, that is longest common prefix. So here you are given an array of strings and you have to identify the longest common prefix string from this. So in this case, FL forms the longest common prefix, so hence that is returned as the answer. However, in the second test case, you can see that none is the longest common prefix, so that's why an empty string is returned as the answer. So now let's directly jump to the test case that we'll be solving in this video. So here are array of strings. Here also the output is FL. So now let's see the first approach. So the naive approach that can come to our mind is that why not start scanning the strings column wise? They can be scanned row wise as well. However, we are going for column wise case in this. So first of all, let's do the initializations in which our answer will be stored. So at the start, I have initialized my string as an empty string, and then I have started a column wise scanning of the strings. So I'll be scanning that all are equal, then I'll be adding it to the string, otherwise I'll be terminating my search. So first, since all f are equal, so that's why I'll be adding f to my final answer. Then I'll be proceeding ahead, since all L are also equal, then I'll be adding that as well in my answer. And as I'll be proceeding ahead, since now there are mismatched, so I'll be terminating my search here and I'll be returning FL is the final answer. So I hope the logic is pretty clear from this. Now we are going to scan about the time complexity. So here you can see that there are n words, and in the worst case we can assume that all are having a length of m. So we can easily say that it can be n into m. Or if we count the number of words in this, then we can write it as O of S, where S represents the number of words in these array of strings. Otherwise, some also say that the time complexity can also be dominant with respect to the count of characters in the minimum string. So as you will scan, and if the word finishes, then the scanning is useless, right? So we can terminate that. So that's why it can also be represented as n into minimum length string. So this can be the time complexity in a specific case if they are varying words length. However, if all are same, then in worst case it will be O of S. So now let's go with the second approach. We assume that you are already aware of the binary search, and that only we'll be using to solve this question further in the second approach. So first of all, I have to find the minimum length of the string existing. The second is applying binary search. So here the minimum length of the string is 4. So now I'll be applying binary search to it. For this, my 3 relevant parameters are left, right, indexes, and mid, right? So left I'll be starting from 0, R I'll be starting from min length minus 1, that is 3, and now I'll be calculating my first mid, that is 0 plus 3 by 2, which comes out to be 1.5, and if I take the floor of it, then it will be 1. So as of now, I'll be treating that as mid. Now I'll be picking up my first word and I'll be dividing it into left and right part. So here I can easily divide this into FL and OW. So now I'll be checking for whether FL is present in every character, in every word. If it is, then I'll be performing a check regarding it. So FL is present in this also, in this also, in this also, in this also. So that's fine. Now I'll be shifting my search space to the right side by updating my low to mid plus 1. So now I come into this search space, which will be further divided into 2, that is O and W. And further I'll be scanning for it. O I will get here, and then not. So this will actually return in a negation, that the final check is not there. That means O is not present in all. So that is why I will be updating my R to mid minus 1. Now this L and R both are pointing to this one only. So that's why my algorithm terminates and I'll be getting FL as the final answer. So when you are talking about the time complexity for this, then we can easily say that since it compares all the characters, so that's why it will be S dot log m time taken by binary search. So this time complexity will be O of S log m and space complexity will be 1. So now let's see it in the form of coding. So I'm just elaborating here the concept of algorithm which uses binary search. So here is a check function which actually checks that substring is present in all of the strings existing in that array. So this is basically checking that if the particular substring is existing in the all the arrays. If they are existing, then it returns true. Otherwise, if the check fails, then it returns false. So this will be used by the main function for checking whether a particular string is there or not. So now let's come to the main function. In this, we have just found the minimum length of each string. Next, we have initialized our L and R and answer as null. While L is less than equal to R, we are calculating the mid, and then once we have calculated the mid, we are checking whether that particular indexed string, that is substring from 0 to mid, is actually existing in those strings or not. So once this function takes the control and it returns a true or false, accordingly the tasks will be performed. If this is successful, then answer will be updated and that substring will be added to the answer and left index will be updated. Otherwise, if it will be unsuccessful, then right index will be updated. Accordingly, when the algorithm terminates, the answer will be having the actual substring which is present in all. So this returns the answer. So that's all. Thank you for watching. Have a nice day.